Okay, so tonight's video lesson is a very, very simple one. Hopefully, after the bells get done ringing, hopefully you found all of these, the two formulas that you're going to use for tonight during class on Monday. So the first thing we're going to look at, and you can see what I have on the screen, is find the length of an intercepted arc. Or the book likes to use big fancy things like that. I like to just say find arc length. So when I find arc length, you came up with a formula that you showed me on Monday that said S equals R theta. And if you remember in the reading before you came up with the formula, we talked about theta has to be in radians to make a nice simple formula. If not, you got to do a little bit more tedious work. It's not hard, but it's more tedious. So you want theta to be in radians. So basically what we're saying is we have some central angle. Remember, a central angle is at the center and there's two radii that are its sides. So this is a central angle. And maybe the measure of the central angle is pi over 4. Kind of a bad scale, but we'll just pretend. And then we know that this radius is 5 centimeters. And to find the arc length, you want to find this length here. Now that you derived the formula on Monday, you can just plug it in. S, the arc length, equals 5 centimeters times pi over 4, your central angle. So the measure of your arc length is 5 pi over 4 centimeters. I don't care if you leave it like that. You can leave it just like that for the test and for homework. If you want, you can figure out what that is. So 5 pi divided by 4 would give you about 3.9 centimeters. And remember, these are measurements, so you'll want to label them. Like I said, I usually just leave them in exact value if I can. If you can't, then round. Let's try one more. Let's say this time we have a circle and your central angle is 100 degrees. And your radius is 2 feet. Let's say we're talking about a wheel or something. And I want to find the length of the arc that's intercepted by the central angle. So this arc right here. And my formula is S equals R theta. We have a problem with this one. The problem with this one is this angle is 100 degrees. I told you theta needs to be in radians, so you first need to convert. So change 100 to radians. So take 100 degrees times pi over 180. And let's see, the zeros cancel. It'd be 5 over 9. So my theta is 5 pi over 9. Plug that in. And I also plug in R, which was 2 feet. So I plug that in. So S equals 2 times 5 pi over 9. So my arc length is 10 pi over 9 feet. And like I said, I leave mine like that. If you want to put those extra steps in to figure that out exact to the decimal place, this is the exact answer. If you want the decimal, you can do that. If you're doing a word problem, you might get the decimal just because most people, you don't want to tell them 10 pi over 9. You'd want to tell them whatever that is, 3.5 feet. Because if you're going to talk to somebody about a word problem, you're not going to want to say 10 pi over 9 feet. They won't know what you're talking about. But for the test, for quizzes, 10 pi over 9 is just fine. So that's the first thing. That's arc length. Should be very, very easy. Plug and chug. The second learning target is to find the area of a sector. A sector is a piece of a circle. And it uses the central angle again. So here's my central angle. If I want to find this piece right here, this piece I'm shading, I use the area of a sector formula, which you derived Monday in class. The area of a sector is r squared theta over 2. Some people write that as 1/2 r squared theta. However you want to write it, those two are the same thing. And remember that theta must be in radians. If it's not, convert. Theta must be in radians. We'll just try one example of this. So here's my circle. Let's say that I have an angle of 50 degrees, a central angle of 50, which we'll say is about here, and a radius of 6 inches. And I want to know the area of this little sector. The sector is part of the total area. Remember when we got that formula in class Monday? So I'm going to plug numbers into my formula. So A, area, equals r squared, so 6 squared, times theta over 2. I left theta there, and hopefully in your head you're saying because theta's in degrees, it needs to be in radians. So over here I'm going to change 50 degrees to radians by multiplying by pi over 180. And it looks like my 50 degrees is going to be 5 pi over 18. So now I'm going to multiply 36 times, so I get 36 times 5 pi over 18 all over 2. So 36 times 5 is 180 pi over 18 all over 2. I can simplify, and one thing, depending on how you wrote it, you know, dividing by 2, maybe I should write this, dividing by 2 is the same as multiplying by 1/2, so that can help you. And you can now simplify this, so if I multiply by 1/2, this becomes 90, and now I have 90 over 18, so I could divide them both by 2, that's 45 over 9. And if I divide one more time, that's 5 pi. That's nice that it comes out like that. They don't always come out that nice. 5 pi, and then I should put my units on there. My units, I'm talking about area, so it'd be square inches. So 5 pi square inches. And that's how you find the area of a sector. For either arc length or area of a sector, the biggest thing you need to remember is theta must be in radians to use these nice, quick little formulas. You have to remember that. Theta must be in radians. That's it. See you in class. Make sure you write down any questions that you have. You can put them in the discussion or ask in class Tuesday.